What?
I want to say it's B, but I might be wrong.
Do you guys remember that quiz I'm talking about? There was one that was like worded exactly like that.
I really
Let
don't remember.
me see if I can find it.
Yeah, we can try and look for it really fast.
I'm getting all my classes confused at this point.
Hmm. What do you think it is, Kelly?
The means.
I want to say B.
Okay.
But I really don't know. Normal.
Let's see here. Let's see. I think it would be B.
B. Sweet.
Okay.
Oh, yeah. B.
Okay, so of the four types of confidence intervals listed below, which one is appropriate for this experiment? I don't know.
Would it be A?
Does it tell us the
No, it doesn't give
standard
us
deviation?
I think it's because we don't know the confidence interval.
Yeah.
Oh wait. For you when
I think it might be D,
D.
because
They are independent samples.
like the female is not gonna determine how the male will react to the thing, right?
Yes. Right.
That's what I was thinking. What do you guys think?
I think so too.
Okay.
Okay.
I guess we'll see.
Yeah.
Oh my gosh.
Bless you.
Okay. Yeah, I have this weird cough that like it's not like bad, it just it's kind of annoying and won't go away.
Oh.
Okay, so number 5.
For this one, I was trying to remember if you had a 99% confidence interval, would that make the margin of error go smaller?
Let's see, I think I wrote down some general rules. So, if n goes up, then the margin of error will go down. So I think it would be B, obtain the balances of 90 bank customers rather than 30.
Okay.
So I just wrote that down from lesson 10.
Mm-hmm.
It was like in the notes, and I just put n goes up, and that makes the margin of error go down.
Okay.
I guess it's good to take notes once in a while.
Yeah.
I'm so bad at taking notes for this class.
Me too.
Seriously.
Oh wait.
Okay.
Sorry. Which one did we say it was?
So if you want to decrease the margin of error, you want to increase the sample size. So it'd be,
Increase obtain a balance of 90. So B.
yeah. That's what I have in my notes anyway. Okay, so number 6.
When I did this earlier, I got B.
Okay.
And you just did the confidence interval formula.
Mm-hmm.
Yeah, so it's the confidence interval when sigma is known, right? Yes.
Mm-hmm.
I need to go grab my calculator. I'll be right back.
Okay.
All right, let's do this. So, our formula, number 6, take the mean, our z-score, since it's a 95% interval, will be 1.96, right? Yes.
Yeah.
Yep.
6 times standard deviation of 2 over, what's our sample size? 4?
Sample size is 4.
Or yeah.
That's tiny.
Yeah, because it's 4 shafts.
Okay, so 1,000 minus, I got A.
Really?
Yeah.
Okay, let me redo it. Maybe I didn't do it correctly.
I'll see. So that's our sample mean. So 1,000 times that. Did you do the square root of the sample size?
Oh, that's what I'm missing.
Oh, that's probably what I didn't do.
So it'll just be 1.96 times 2 divided by 2. So it'll just be 1.96 because 2 divided by 2 is just 1. So.
Oh, yeah. Okay, that's what I did wrong. Okay, yeah, I got A2 then.
All right. Is that what you got, Kelly?
Yeah.
Okay.
Yeah, I'm looking at number 7 now.
7. So we need to use the sample size formula. So that is n equals, do you guys have that formula?
Yes, n equals parentheses z times, what is the O, sigma?
The sigma.
Sigma divided by m, and then all of that is in parentheses, and then it's squared.
Yep. So our z value is going to be 1.96 times 0.01 divided by 0.00001. Yeah. All that squared. Whoa. I got C.
38416.
Yep.
Yeah, I got that too.
Yeah.
Sweet. So far, so good. Okay.
All right, number 8.
Since it says that it thinks that the apartments are smaller, would it be A?
Yeah. That's what I was thinking.
Okay.
Yeah.
Is that just because of the wording?
Yeah, so the null hypothesis is that it equals 1,250, and
Mhm.
it says that a tenant group thinks that the apartments are smaller, so they think that the mu is actually smaller than 1250.
Oh, I
So
see.
so the HA would be U is smaller than 1250.
Okay. Wow, we really have to be careful on the wording.
Yeah. Yep. Okay, so number 9.
Is it A again?
Ooh. Well, because I know the variance can change, but that's not necessarily the same. Because that's like a value of 0.05 is just like corresponding to a 95% interval.
Mm-hmm.
And so A can be like 0.1 or
Yeah, that can change.
so I think for it to be significant, the p-value has to be less than A, right? Because if it's less than A, we reject the null hypothesis.
Uh-huh.
So yeah, I think it would have to be less than A.
Okay.
Because if it's not less than A, then it's not significant enough to reject the null hypothesis.
Okay.
Does that make sense?
Yeah, that makes sense.
All right. Oh, number 10. A group of statistics students. Hmm. So the ANOVA, let's see.
Has 6 variables.
So it says the ANOVA is used to compare the means for several groups. All the means are equal, and the alternative is at least one of the means differs. So,
I don't know, because do they have enough data?
I don't know. That's a good question.
So it's sample size.
So,
So
yeah,
it's
like what are
sample
the
size. So it's
requirements?
15 out of those 4 apartment buildings
So I think I think they're taking 15 from each of
each.
the 4 different apartment buildings.
So I think they do have a good.
Yeah,
So
I think it's
if we think back to like our quiz, do you guys remember how like the letter A had like 15 things in it and letter B had like 15 things in it,
Mm-hmm.
right? You guys kind of remember that?
Yeah.
And like the socks had like 15 different data sets for them.
Oh yeah.
And then we kind of did the means for all the different ones.
Uh-huh.
So I think it would kind of be the same idea for this one.
Okay.
But do we need to use SPS on this thing?
I don't
I
think
don't think
so.
so.
No, we just have to determine if we needed to, if we could, kind of thing, I think.
The data for each apartment building are bell-shaped with no outliers and the sample variances are nearly equal.
What does it mean by no outliers?
So there's not like one person who's getting like a 4.0 compared to everybody else getting like a 2.5 GPA. So like say like the mean is like a 3 point or like a 2.5 and you have a person who gets a 4.0, they'd be an outlier compared to the mean.
So no outlier.
So I think since the variances are nearly equal, it should be A.
Yes,
Okay.
I concur. I was thinking like the no outlier meant that it wasn't going to be right skewed.
Oh, no, I think it still would be.
It still would be. Okay.
Well, it says there are not any outliers, so I think we're good. I think it would be A.
Yeah. Okay.
Okay, number 11.
No, this is from like the first chapters.
Yeah. Oh my gosh.
Hey, no. Hey, get off.
So I was just reading over this, the type 1, type 2 errors. The type 1 error is committed when we reject a null hypothesis that is true, that is actually true. So we got to figure out, in this example, they're saying that the null hypothesis was actually true. Is that what let's see. So what is the null hypothesis for this thing?
It says,
So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. And then later it says, in a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients. So I think that would be a type 1 error. Do you guys agree?
I'm reading it one more time.
Okay.
You said type 1 error was when they reject the null, but it turned out to be true.
Yeah, so it says a type 1 error is committed when we reject a null hypothesis that is in reality true. So if it says
Type 1.
the null hypothesis is that the average survival time after diagnosis is the same for the new and the standard treatment.
Yeah, I think it is a type 1.
Because it says later in a future study, it is determined that the new treatment does not increase the mean survival time,
Yeah.
which is what their null hypothesis was. Do you guys agree or have any other?
The
Go
error is
away.
that she rejected the null hypothesis. The null hypothesis is true, but she ended up
Rejecting it.
rejecting it.
Yeah, so that would be a type 1 error. Yeah. Because it said type 1 error is committed when we reject a null hypothesis that is actually true. All right, number 12.
I think it's D. Isn't it if you reduce the probability of one, then you increase the other one?
Yeah, we had a question like that, a quiz question like that before.
Yeah.
I remember that one. This is way back from like lesson 12 or something, isn't it?
Yeah.
Okay, 13. We're almost halfway there. Oh, I forgot how to test this hypothesis. Garbage.
Hey, stop it.
So,
Whoops. Uh,
So we need to find the p-value, right?
Yeah, the p-value tells us if we reject.
hey, stop it. Grumpy dog.
So is this just wanting us to do a z-score? Or like a z-score with...
I think is this from lesson 9?
It might be.
It's giving us an x.
You think it's what?
Well, it's giving us the x with the bar, so I remember something like that had to do with like a formula, didn't it?
Yeah, so there's a formula that's z equals x bar minus the mean over standard deviation divided by the square root of n.
Oh. Oh,
And then
wait.
we could use that to find our p-value.
Yeah.
So let's try it and see what we get. See if we, I don't know, we'll see what happens.
Trying to look for that formula.
It's back in week 3.
Oh, that's like way back.
Yeah.
Oh, here we go.
Okay, so 1.53.
Was this the regular z-score?
No, it's like the special one with the x bar minus the mean.
Oh, okay, with the square root n.
Yeah, that one.
I see it.
Divided by. Okay. Right. All right. Let me know what you guys figure out for the z-score and the p-score afterwards.
Mm,
Did you get the z-score as 1.76?
Yep.
Okay. I need to get my applet up.
And then we plug that into the area, right?
You plug that one into the z-score at the bottom.
Plug that one into the z-score bottom.
Mm-hmm.
And then you want to highlight to the right of it because the question asks what's the probability, or like they want to test if it's higher. Because the alternative hypothesis is that the mean should be higher than 1.5.
Okay.
I get p-value as 0.0392.
Okay, that's what I got. So at the 5% level of significance, that's equivalent to 0.05. So p-value is less than 0.05. So we would reject the alternative hypothesis, right? Or is it only rejecting the null hypothesis?
You failed to reject the null.
So it would be B.
Yes.
So it says if the p-value is less than A, we reject the null. If the p-value is not less than A, we fail to reject the null.
So you reject the null. Would be A.
No, it would be D.
Oh. Oh, yes, D. Sorry. Yes, D.
14 is D?
13.
Oh, 13.
Because P is less than this level of significance.
Right.
Okay, 14.
Would it be paired since it's 2?
I think so.
Hmm. So for paired, what isn't paired where you like find the difference between them?
Mm-hmm.
Yeah, I don't think it's paired. I think it's independent.
Yeah, because the paired would be like something like the first group affects what you get in the second group.
hmm
So like if you're doing it for like couples and you interview the husband, you're gonna have to then you're bound to interview the wife because they're a couple together. That would be like paired.
Okay.
So I think it is D, independent sample t-test. But wait, it says you would like a random sample of 100 for each group and test if those means are different.
I think you're right, though. I think it's independent. Because 15, I think, is dependent when you read that way.
Okay, let's see. Yeah, that would have to be dependent.
Mm-hmm.
So it would be D, right?
Yeah.
Because if you select the brother, then you have to select the sister who's right next to him.
Yeah.
To go to my workout or not to go?
Okay, 16.
I believe in you.
We gotta open a data file just so you guys know.
Oh, that sucks.
So the data file is dissolved organic carbon.
Oh.
Wait, where do you get the data file?
Well, I have it saved as a bookmark on my bookmark pages from when we had to do it from a lesson before.
I just have the book open and then like usually within the lesson there's a file
Yeah.
Yeah.
and if you click on it it'll make you
I'm trying to find where the file is.
go to chapter 14.
I did that, and then once I got that page open where it had all the data files, I saved it as a bookmark so I could just click on it fast.
Yeah,
Yeah.
that's smart.
Okay, I'll find it.
Okay. Well, you'll probably be good because mine is still loading.
Yeah, this always takes forever. Why are we using this program anyways? Like, who else uses this?
I don't know.
I'm just surprised we don't use Excel because, like, I don't know, I would think that in the real world you're going to be using Excel instead of SPSS.
Yeah.
I don't know.
Well, let me pull out my SPSS, guys.
So it's dissolved organic.
Carbon.
Oh,
So, I don't think it would be D or C. Because we don't know the mean of differences. You know.
mm-hmm.
Because it just gave me one row, one column of numbers. Is that what it gave you guys?
Yeah.
Mine's
Yeah.
still loading.
Okay, so soil scientist class.
Here we go.
Maybe A.
See, that's the tricky question. Is like we could go through and find sigma, and then it would be A. But if we just assume that we don't know sigma from the beginning, it would be B.
Hmm.
You know what I'm saying?
Yeah.
But when we plug it in, don't we know sigma?
I don't remember, to be honest. It's been a long time.
I think you're assuming that you don't know that off of
For
the
this
information it's giving you.
situation, I think it's B.
Okay, you're probably right. I think you're right. I think it is B. So which of the following is the 95% confidence interval for these data?
Mm-hmm.
Let's see. For that, I forgot what we do. So we need to go analyze, compare means.
17, I got D.
For which one? 17?
Yeah.
Me too. Yeah,
How'd you guys do?
you just go to analyze and then compare means and then one sample t-test.
Oh, yeah.
Okay, thank you. I just couldn't remember how to do it.
That's fine. We learned like 10 different things to do on this program.
Seriously.
Oh, yeah.
Okay. So
Well, we gotta open a new file. So human, no, not human. Hummers, LA, in New York. Oh, where is it?
Used Hummers.
so that now we're done with that data file.
Yeah.
Yeah.
Sweet.
Oh, I think I closed my window and I lost it. No.
I'm not seeing a Hummers.
It's used Hummers.
It's used cars?
It's used
Yeah.
Hummers.
Oh, thanks.
Oh, here it is.
So wouldn't it be, nope. Did you guys decide what 18 was?
Not yet.
So is this one a pair? Are we doing a paired sample test or a two sample test?
This would be a two sample test. Well, let me, oh, that's a good question actually. So it would be paired. Actually, I don't know.
So would 18 be D?
18 be what?
D?
D as in dog?
Mm-hmm.
I think so.
Okay, cool.
Because, yeah. So, difference of mean. So, we need to go through.
Oh gosh.
We need
Do
to
we?
automatically.
Yeah. Do we need to recode? No.
I would think so. Because it wants to know.
Yes, because there's there's a model H3 and H2.
So, we need to do model as the new name.
I guess.
So,
So you
wait, no. It would be. The new one would be location, wouldn't it?
wait, maybe I should look at the question.
Yeah, so it wants to know the mean listing prices between Hummers from LA and New York.
So it is
So
location.
we need to categorize them by location. So location is going to be our new,
Or by city.
yeah, by city.
Okay, so transform, automatic recode,
Yep.
and then city. Put that in your variable. New name, illegal character. Oh, wait, did I put a space? So picky.
So the price is our test
What?
variable is codes, group variables, define group.
Okay. And so after you create the new, can't remember what you do.
So you got the you got the new one on there?
Yeah.
You have to speak up. I can't really hear you. Sorry.
I'm just, yeah, so I got the new column or whatever, but,
Okay. So then you go to analyze,
okay.
compare means, independent samples t-test,
Okay.
and then you'll have to put price in your test variable, and then the new one that you just made into your grouping variable. And then you'll have to hit define groups and put the number 1 in the group 1 spot and the number 2 in the group 2 spot. And then you should hit OK, and that should give you all the good stuff.
What did we decide was the test variable?
Do we need a test variable for that one?
Is it the price?
Oh,
Yeah,
the
you know
test
how.
variable.
Yeah.
Yeah. Test variable, sorry.
Okay.
Because it wants to know the true difference of mean listing prices between Hummers from LA and New York.
Okay.
So yeah.
Oh, I think I got a weird answer. Oh, no, I didn't. No, yes, I did.
What did you get?
I got a really big number. I think I did this wrong.
So I got C. Answer C. So I got.
Actually, you got 427?
I got negative. So you use the bottom numbers when it comes out and gives you all the information.
Okay. So yeah. Yep. Sweet. I got C.
Okay.
Okay, I got C too.
Sweet. Okay.
20.
Yay.
Now we need to open exercise bone density.
At least we're figuring out how to use these stupid programs.
Yeah. Let's true.
Exercise, bone density. Only 7 questions left.
We're almost there. Are you guys gonna take the
Honestly,
test on Saturday or before?
I wanted to take it tonight, but it's not open. Because I have to
Oh,
go to Utah this weekend. And I'm from Idaho, so I don't want
no. Your drive isn't that bad.
Yeah, I just don't want to have to worry about it when I'm down there.
Yeah, that's true. And you can't have any fun because you're just stressing about the test.
Yeah.
No, actually, I think I'm gonna be in Utah sometime in March.
Oh, really?
I might miss a meeting.
That's okay. I've missed a meeting.
Okay. Yeah, yeah, 'cause my flight is like during the meeting.
It's all good.
You can still make it.
Just get some Wi-Fi on the airplane.
Mhm.
Would
Okay.
20 be B because there's not a standard deviation known?
I haven't even read it. Sorry, I'm a little behind.
Wow, my program just loaded. Oh, I guess I didn't need to wait.
Would it be independent samples?
Let's see. I'm gonna
Yeah.
read it real quick.
Okay. I think it's independent too.
Yeah. Okay, so number 21, calculate the test statistic. So we're just trying to find T.
Mm-hmm.
Mm-hmm.
So we need to recode the treatment. Automatic recode, blah blah blah, treatment codes.
Test variable. The test variable, is that the rat bone density?
The test variable would be yes.
And then the grouping would be the treatment code.
Yeah, that'd be the new codes that you put in there.
I always have to like think about that.
I just remember that whatever you change, whatever you make new, goes into the
The bottom.
grouping. Yeah.
Okay.
So
The test statistic.
I got a
Um,
negative 3.715.
that's what I got.
What the heck?
So I guess we all did something wrong.
Wait, what did you get?
Negative 3.715.
Is it what?
Wait, is this um never mind.
That's weird. We aren't even like close. What did we do wrong?
So
Is
you're
that what you
looking at
guys?
T, right?
Yeah.
Yeah.
I got 128.7. Still wrong.
Are we supposed to do the analyze descriptive statistics?
Maybe. Guess we can try. Explore. Wrap.
No, maybe not.
That's so weird. I don't even know. I'm getting the same value for T. Well, let's figure out. Are we sure it's the independent samples t-test?
What's the one-way ANOVA?
Because couldn't we use ANOVA since
Isn't ANOVA independent, like some form of independent variable as well?
I think we would have to use ANOVA actually.
I think so too.
I just forgot how.
Compare means one-way ANOVA.
Oh yeah, right there. Yep. Okay, so dependent and then your factor would be your codes.
Yep.
Let's see if that gives us, and then go to options and do descriptive
Yeah,
and leads.
here you go. This is right. It's the third one. So we need to change.
7.9.
Yeah, we need to change 20 to ANOVA.
ANOVA. I think the big hint to that is in the question it says researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats.
Mm-hmm.
So since they're doing 3 different groups, it would be the ANOVA.
Yeah. And so 21 is C, and then 22 is B.
Wait, what did you get for 22?
0.002.
Okay, so 22 is B, and then 23 is so it's smaller.
Smaller. I'm actually not good at these. I get these wrong.
Okay, let's see. When do we need to do the variance? Because this is where we have to figure out if the variances are 4 times the size of the smallest one. Or do we just use the or do we just use the p-value?
I think both.
Okay.
Where's my ANOVA notes?
Well, so if you do it the one way where the smallest variation is less than, let's see how, okay. The largest variation is not 4 times greater than the smallest variation. So in that way they are the same. I think it would be A.
That's what I was thinking.
I gotta go grab my charger, my phone's about to die.
Wait, so why is it A again?
I'm not sure.
There was that one
So-
note where it had to be 4 times. Oh,
Oh, the rules to it.
Yeah.
Why is it giving us the level of significance? Is that just to throw us off?
It might be,
Oh, that's not nice.
but 'cause I don't remember using ANOVA and the level of significance before.
I just remember seeing it from reading the chapter.
For the ANOVA one,
Yeah.
let's see. Oh yeah. So the p-value of an ANOVA test is always the area to the right of the F statistic. So I guess there is p-value involved. But since the p-value is smaller than the variance, wouldn't that mean that I can't even speak today. I don't know.
So if the p-value is smaller, that means we reject the null.
Yeah.
So does that mean there's insufficient evidence?
I think it would be there is insufficient evidence to conclude that the bone density of all three groups is about the same. Right?
I think
Mhm.
so.
Yeah.
So what's the null hypothesis, I guess? Researchers would like to determine if the mean levels of bone density are different between the three different groups of rats. So they want to know if they're different.
Uh,
It's a tricky question, I'm not sure.
I don't know.
That one's kind of tripping me up, to be honest. Let's see. Let's talk about what we know. So the null hypothesis that they want to find out, or that they believe to be true, is what? So it says they would like to determine if the mean levels of bone density are different between the three different groups. So is that their alternative hypothesis, or is that their null?
I think that's the null.
So
I don't think they gave an alternative hypothesis.
if the p-value is smaller than A, then we're saying that they're not all different. We're saying that they're all the same, right? Because if we reject the null hypothesis that they're all
Right.
different, we're saying that they're the same,
Okay.
right? I don't know.
Yeah. So then it is A?
I'm not sure. I
I think we're overthinking it.
think we are too. Maybe let's come back to it.
Maybe we just need to. Maybe they are tripping us up with the level of significance.
I don't know.
Yeah, let's come back to it. I think if we come back, we'll have fresher minds to think about it again.
Okay.
Okay,
Well,
so direct flight costs. So many data files. What do you think, Kelly?
I have no idea.
Okay.
Sorry.
No, it's good.
Oh, I feel like we had a question like this.
We had an exact question like this, actually.
Mm-hmm.
Does anyone remember?
Is it
Nope.
dependent?
So it was. Oh, where was that?
This was on our last quiz.
Was it on the last quiz? On the last homework quiz?
Yeah.
So that would have been chapter 13.
Yeah, 13.
Because I remember that was like an exact question.
Mm-hmm.
Yeah, so it would be. So it's a paired sample t-test. It's 2 tallied.
So it's dependent.
Yeah, what is the question ask?
Indirect flight cost.
Yeah, so it's dependent. Alright.
Okay. I got,
That's
for 25, I got A.
Me too.
okay.
I'll
And
go with it.
26, I got B.
Me too.
26, you got B.
Yeah.
Yeah.
Oh,
Yeah.
27.
26 as in boy.
Yeah.
Yeah.
Okay. 27. Oh,
Tickets purchased 14 days in advance, covered 9 days in advance.
Was this question in that quiz too? If you have
yeah,
it up.
it was the same p-value, but the question wanted to know for a variance of 0.05.
Hmm.
So it'd be almost the same.
Yeah.
So the quiz question said, can you say that there's a difference in the cost of airline tickets purchased 90 days in advance compared with 14 days in advance? And the right answer is no, because the p-value was greater than the level of significance. But in this case, since the p-value is less, you would say that there is.
So it'd be B.
B. Yeah. There's a
Yeah.
difference.
So then let's look at 23 again.
Okay.
So then this one, the p-value is less, so we're rejecting it.
So there is sufficient evidence.
So it's A.
But what is their null hypothesis, though?
0.5.
I thought we said the null hypothesis would be that the levels of bone density are different between the 3 different groups. So they're saying that it's different between the rat groups. And since we're rejecting that, we're saying that they're the same.
Yeah. So wouldn't it be?
Should be A.
Yeah.
I
Okay.
guess we'll find out if it really is A. I'm
All right,
submitting it. I'll let you know.
96.
We did good,
We
you
only
guys.
missed one.
We did get it wrong.
It was B.
It was B. Oh, that is so tricky.
Yeah. Hey, well, we did good.
Yeah. It's too bad we can't take the test together.
I wish that would just be our test.
Yes.
Yeah.
Hopefully it's the same questions.
That didn't even like change my grade at all. All right,
Alright.
guys. Good work.
Good. Yeah. Good luck.
Thanks.
Have a good weekend.
See you guys.
Bye.